everyone. Today we're going to be looking at how are we graphing functions. So we've talked about writing function rules. We've talked about using substitution in order to evaluate functions and then creating ordered pairs from those outcomes. And now what we're going to do is we're going to take everything that we've learned so far and we're going to apply it so that we are able to graph. So we're going to have a problem that will ask us to graph the equation y equals negative 2x plus 1 when x equals negative 1, 0, 1, and 2. So if you remember in a few lessons back, it asked us to graph a linear equation, but they didn't give us what the x value was. Well, today they're going to, well, for the most part, give you the x value. So you just use the inputs that they give you to find whatever the output is. Then from there, we can make our ordered pairs. So our problem looks like this. Y equals negative 2x plus 1. In order to evaluate, we saw that we needed to just use substitution so that we could solve for y. We're going to do that exact same thing, and then we're going to make an ordered pair. So our job is to use this equation and substitute in each of these values. So I'm going to just solve each one with a separate color so that you can see you're actually solving 4 different equations. So in the first equation, we're going to look at x equaling negative 1. So really this says y equals negative 2 times negative 1 for our first value plus 1. So then we're just going to keep going. Y equals negative 2 times negative 1. So negative times negative is a positive 2. Plus 1, which equals 3. So y equals 3. So when x, our ordered pair then we're going to put over here is going to be negative 1, 3. So that is our first ordered pair. And we could even make this into a table of x values and y values. When negative 1 is x, our output is 3. And then that's how you get your ordered pair of negative 1, 3. Okay, so let's go ahead and do a next one. Our next problem looks like 0 is going to be our x value. So we're going to use this exact same equation as the first time and say y equals negative 2 times 0 plus 1. So negative 2 times 0 is 0 plus 1 gives me 1. So y equals 1. So when the input is 0, the output is 1, and that gives us 0, 1. And again, I always forget that second parentheses there. Okay, let's look at what happens when we use substitution of 1. So again, I'm going to use the same y equals negative 2x plus 1. I'm going to substitute for 1, so negative 2 times 1 plus 1. Y equals negative 2 plus 1, and that gives me 1. I have negative $2. I add 1, so I have negative 1. So my input was 1. There's my input. My output, or my y value now, is going to be negative 1. And my ordered pair is 1, negative 1. Okay, last problem with this example here. I need another color. Okay, let's go with this like green color. it says when it's 2. So we're going to solve again. So when the input is 2, what's our output? So y equals negative 2, x plus 1, y equals negative 2 times 2 plus 1, or negative 4 plus 1. So y equals negative 4. I add $1, I get negative 3. So my output is negative 3. My ordered pair is 2, negative 3. Okay, so this is yesterday's lesson, except we just did the same problem over and over again 4 different times. So what we're going to do now is we're going to add it to today's lesson, which is about graphing. So grab your handy dandy sticky notes, and we are going to do some graphing of these ordered pairs. All right. Where's that pen? Okay, so I'm just going to go ahead and stick this right in here. And again, your Post-its happen to have the middle already marked for you, so you have your ordered pairs. Your axes here. Can I help you? Okay, you gotta get down. Sorry, buddy. Apparently my dog wants to graph with us. Okay, so now we're gonna start with our first ordered pair of negative 1, 3. So on our graph, we're gonna go over to negative 1, and then we're gonna go up to 3. 1, 2, and 3, and that is our first dot. Okay, next, you're being stubborn today. We're gonna go 0, 1. Okay, so 0, 1. We're gonna start at 0, and then we're just gonna go up to 1, and then put our dot. Our third point is at 1, negative 1, so I'm gonna start at 0, 0, go over to 1, and down to negative 1. And last but not least, we have 2, negative 3. So I'm going to go over to 2 and down 1, 2, and 3. I'm then going to connect. And I have my function all drawn out. Again, this is a function because none of those values in the x repeat. It forms a line that does not touch on the x-axis a second time. So if I were to do the pencil test, it only hits the line at one point on the y or on the x value. So this is a function. So we can determine if it's a function or not. So this one is yes, it's a function. Okay, so we have a couple different things that we're putting into this process. You are solving by using substitution, creating ordered pairs. From your ordered pairs, you're then plotting the dots and connecting them to determine if this is a function or not. Okay, let's do another example. And we're going to call this one example B. So in example B, oh, where did my example B go? Where did you go? All right. So in example B, we are going to say we're using this equation, negative x plus 3. So y equals negative x plus 3. And I want your x values to be negative 1, 0, 1, and 2 again. So x equals those values. So let's go ahead and start to solve. So I'm going to make another table again, just like I did before, to help me organize my work. My input, first up, is -1. So I'm going to go ahead and solve this problem. So y equals negative, remember that there's like a 1 here. So this is really saying -1 times a -1 plus 3. A negative times a negative is a positive. So this is +1 plus 3, which gives me 4. So y equals 4. So my output, my ordered pairs are 1, 4. Again, remember that when this is just an x, a negative x, it's like having that 1 in front of it. They just don't put it in front because it's kind of redundant to do that. Okay, so let's do it again. This time we're going to use 0. So our x is 0. What's our output? So this says y equals -1 times 0 plus 3, or 0 plus 3, which is y equals 3. So here we have 3, 0, 3. All right, next problem. This time we have 1, just like before, so we're going to substitute in a 1 when x equals 1. So it says y equals -1 times 1 plus 3, or -1 plus 3. I have -1, I add 3 to it, and that gives me a +2. So y equals +2. So over here, I'm going to put +2 and make my ordered pair 1, 2. That's my next point. Okay, last one. So this is my last time solving for this because I had 4 values for x, so 4 equations. Y equals -1 times 2 plus 3. -2 times -1 times 2 is -2 plus 3, which gives me 1. -2 in the bank, I add $3, I have $1 left. So when my x value is 2, my y value is 1, and my ordered pair is 2, 1. Okay, now I am ready to graph this equation. You can graph it on the same graph paper that you used last time, so that way you're not wasting graph papers. Or if you prefer to have it separate, you can do it separate, no problem. All right, so let me draw out my axes here. Oh no, that looks awful. I'm so sorry. Okay, this pen is dying. It's time for my new one. Okay, my first point is -1, 4. So I'm going to go over to -1 and up 4. So start at 0, 0. Go over 1 and up 1, 2, 3, 4. Then put my dot. So otherwise, I'm not touching the graph until I put my dot. My next point is 0, 3. So again, I'm starting at 0. I'm not going anywhere. And then I'm going to go up 3. 1, 2, 3. There's a dot. Next one is at 1, 2. So back to the origin. Go over 1 and up 2. 1, 2. And the last dot is at 2, 1. So I'm going to go over 2, 1, 2. And up 1. Put my dot. And now I'm going to connect these, and it makes a straight line. And we know that straight lines only, it only has one x. So this shows, this line at an angle shows that it has a negative slope. It also shows that it is a function. So this one is a function. I don't think you need to, identify functions quite yet, but we're practicing as we're going. So right now you're seeing examples of functions. So hit pause so that you can finish writing this one down. Otherwise, I'm going to turn the page so that we can do our try its. Maybe we'll just do one try it today. All right, so let's just do one try it. If you need an extra try it, let me know. You can always come back to the Google Meet and ask for another try it if you need one. But I want to make sure that we have enough time for this. So let's do graph y equals 3x plus 2 when x equals -1, 0, 1, and 2. If they do not give you the values, go ahead and use these same exact values throughout the practice work today. All right, so hit pause right now so you don't hear me solving, and then when you're ready, come on back and hit play so you can see how to solve. All right, again, I'm going to make an X column and a Y so we can have our dots, and then we want our ordered pairs out to the side. So first substitution I'm going to do is -1. So Y equals 3 times 1 plus 2, and 3 times 1 is 3 plus 2 gives me 5. So Y equals 5. So when I have, oh, I messed up. So that's -3. It doesn't. My apologies. I was going too fast. -3 plus 2 is actually -1. Okay, so when it's -1, it gives me -1. I apologize for that. I went way too fast and forgot my negative sign. So check yours. Make sure that you have the right thing there. Okay, now let's keep going. Ordered pair then is -1, -1. Okay, the next problem is 0. So Y equals 3 times 0 plus 2. That gives me 0 plus 2. So Y equals 2. So when X is 0, Y is 2. So my input is 0, my output gives me 2 for that ordered pair. Okay, 1, now let's look at 1 and this problem here. So Y equals 3 times 1 plus 2. Good thing I already did this one, huh? So 3 plus 2, which gives us 5. So Y equals 5. So when we input 1, our output is 5. So 1, 5. And last but not least, it's going to equal 2. So Y equals 3 times 2 plus 2, which is 6 plus 2, which gives us 8. So Y equals 8. So when our input is 2, our output is 8. And that gives us 2, 8. Okay, we're going to go ahead now and take this one step further, and we are going to use our graphing sticky notes so that we can graph this problem. I don't know, you might not have enough grids to graph 2, 8, and that's okay. If not, just do those ones. Or you can recount these, but that would be hard to count for the negatives. Okay, start at 0, 0. We're going to go over -1, 1, put our dot. The next one is at 0, 2. So 0 and then up 2, 1, 2. Our next one is 1, 5. So I will go over to 1 and then up 1, 2, 3, 4, and 5. And last but not least, 2, 8 over 2. 1, 2, and up 8. 1, 2, 3, 4, 5, 6, 7, and 8. If you had enough room on yours, awesome. If not, don't stress out about it. All right. Connect the dots. We get a line, and our function has been graphed. So we've graphed the function. Each x is only used one time in order to get a y value. All right, now you're going to go ahead and answer your essential question. How do you graph functions? And then out to this side, put your level of understanding in the box. And then when you are all finished, you can either come on over to the Google Meet and ask for help or some extra examples, or you can go off and do your practice work. As always, I appreciate all of your hard work and effort, and make it a great day.